thing you do. What's step 0? Step 0, come on.
See if it's equal to 0.
What?
See if it's equal to 0.
See if the limit is equal to 0, right? Everybody agree? So I'm going to say the limit as n approaches infinity of 1 over n is equal to 1 over infinity, which is 0, and that's okay. It might converge. I'm telling you, it's worth the discipline to make yourself do that, because you're going to save yourself a lot of work. Last semester in Cal 3, I put one on the test where the limit of the nth term was not equal to 0. And the class did all 8 tests on it. And all they had to do was do the 0 test on it, huh? Okay? Now, that's the first thing. The next thing is, you don't even have to tell me why. Can't you by inspection? That means just looking at it tell that it's not a geometric series. So do you see I'm going down the line? Everybody follow?
I got a question. It's kind of off.
Go ahead.
You talking about this equal sign you put on there? Is that something that we need to not do? Or
Where?
you just said the sum is equal to, then you put 1 and 1/2, 1/3.
No, that's okay. It is equal. Here's what is not equal.
Just okay. You got to keep the dot.
Yeah, because it isn't our index understood 1 to infinity, and that most definitely is not 1 to infinity. But aren't you telling me by those 3 dots? Don't 3 dots in our world today mean keep on going?
Okay.
Okay. So here's what I want you to notice. Do you notice the way I attack these? I do 0, I do 1, and then I do 2. I'm giving them to you in this order for a purpose. I'm giving you the easier ones first. If one of these easy ones work, then you don't have to mess with the harder ones. Make sense to you? Okay, this is did I not say change the n's to x's and integrate? Now here's my question. Where did I get the limits of integration?
Since it was a standard summation.
From the sum. From the sum. Because I didn't write them, doesn't that mean the sum is from 1 to infinity? So the rule's real simple. The limits of integration are whatever the limits of the sum are. Okay? Alright? What's the integral of 1 over x?
Natural law of x.
Natural law of x. And from 1 to infinity. In infinite series, I loosen up a little bit from Cal 2, and it would be okay with me for you to write But log 1 is 0. Don't believe me? Try it. E to the what power gives me 1? The answer is 0, right? But what's the log of infinity?
$20. Infinity.
Draw graph, if x is 1, y is equal to 0. Isn't that what the natural log function looks like? And it's going to infinity. It's taking its own sweet time to get there, all right, but it is going to infinity, isn't it? So isn't that infinity? What do you think IT stands for?
Integral test.
Bingo. Pretty cool, isn't it? And think of how many integrals that will work for. A whole bunch, huh? Ed?
Yep.
Everybody get it? Okay. How about this is example 4 on page 573. What am I thinking? Am I right? N equal 1, N equal 2, N equal 3, huh? Everybody agree? Everybody agree? You had to nod to help here. Okay, thank you. Beth, nod your head. I need to require affirmation. Okay. Also, I have a reason for writing it out. Why? Don't I have to know that it's decreasing? Isn't that one of the conditions for the integral test? And further, I need to know that aren't those the two conditions to use the integral test? Hmm? So, step 0. Don't you wish that was all you had to do? Wouldn't that be nice? But oh, alas. Everybody agree with that? From just looking at it, huh? Agree? Okay? Anybody besides Ed and Beth remember what that is?
It's like tangent or
Very good.
Like that.
What kind of tangent?
Inverse.
inverse tangent.
Yes, that's exactly it. That's exactly it. Very good. Inverse tangent. Or is arctangent the same as inverse tangent? Isn't it the same thing, just written a different way? And you know why I do that? I like arctangent better is because I don't like that -1 up there. That -1, if you're in a hurry and see that -1, wouldn't you be real tempted to put it in the denominator? That's why I don't like to use it in these harder problems, because all of us, did you hear me say us, not you, are concentrating on these problems, and that's when you make a stupid mistake like that. Okay? Let's do the easy one first.
That's 1 or 0.
What, Ed?
Are you going from 1 to 0 or?
Oh, thank you. Thank you. Let's do this one first. What is it? What angle, don't answer Ed, what angle has a tangent of 1?
So that's 45.
It does indeed. All you do is put it in your calculator, right? If you didn't know, you're supposed to know that now. But remember, you can't use degrees, huh? And 45 degrees is pi over 4, right? What angle has a tangent of infinity?
There is none.
Yeah, there is. You know how I remember that? The sine over, the tangent's equal to the sine over the cosine, right? So all I have to do is figure out where is the cosine equal to 0. Isn't that the way you get infinity, is 0 in the denominator? And where is the cosine equal to 0? 90 degrees, right? And 90 degrees is pi over 2. That's the way I remember it. Okay? But remember my fail-safe method. My fail-safe method is this. Everybody agree with that? Everybody agree with that? Yes or no? How about that? That's the way I do it without a calculator. And you don't have, I obviously do it more than you, but I can draw that in my head. I can, if you see me stand here a minute and look up towards the roof, I'm drawing that picture in my head is what I'm doing.
How does that equal infinity, though? I mean, it should be.
Say what?
How does that equal infinity?
If you divide a slice, let's see, if you have a pizza and you share it between 2 people, or you share it between 100 people, which one gets the bigger slice? When you share it between 2, right? So the smallest slice you could have would be share it with 0 people, which would give you an infinitely large one, huh? Okay.
I see what you're saying. So you're saying it's not really 0; it's really close to 0.
No, I'm saying that x right here is equal to 0, isn't it? And any time you divide any number divided by 0 is infinity. Is that true? Except 0, huh? Except 0. Did I tell y'all about this happened in 1973?
Okay, that makes sense.
1973. I was teaching the math at Louisiana Tech, finishing up my graduate degree, and was a graduate assistant. If you were going to some of you've been to other colleges and you've had graduate assistants. And you know how I try to make real examples, huh? I said to the class, I said, so what is 8 divided by 0? And they told me it was infinity. So I put, here was the test question. The test question was, if you divide 8 by 0, you turn it on its side, right? That's a true story, y'all. I will never forget it to the longest day I live.
Well, that's on a website, Strange Math Answers.
Do what?
It's on a website, Strange Math Answers.
Oh, is it?
Yeah.
Well, that happened. So that limit is equal to 1/2 minus, pi over 2 divided, pi over 2 minus pi over 4, right? 2 pi over 4 minus pi over 4 is pi over 4. And what does that tell you?
Converges.
Converges by, and I do want to see IT. I want you to name which test it is. I will tell you this, by no means are you required to put number 0, number 1, and number 2. You are not required to do that. But if you were to do that, I would know that number 2 is the integral test. But if you don't put that, and I certainly am not going to make you do that, just remind me that it's by the integral test. And this one a minute ago, this one, This one, I told you that the reason it converges is because of the geometric series test. So you gotta show me how you got to it converging. You gotta say that it converges, and then you gotta name what test. Okay?
And with geometric series, we would have to say the rate at which it's changing.
Do I?
If it's a geometric series, we'd have to say the rate.
Yeah, I consider that a part of explaining it. And Josh, the only reason I do that is, isn't that what makes it a geometric series? It's just like the integral test. When you write out the integral, isn't that's what makes it an integral test? That's why. I've dealt with too many con men over the years, and that's why I make people tell me things like that. And I teach math different than other people. I'm testing to see if you understand what you're doing. And that way you're showing me you do. Okay? Now, here's one that's sort of interesting. This is example 3 on page 373. Ed, what kind of series is that? It's a power series. That's a P series, huh? It really is a power series because it's 1 over n to the P, isn't it? But for right now, we'll call it a P series. So this will be the P series test. Okay? This is the P series test. Okay, and it has to be, it is used when a number is in the numerator and a power of n is in the denominator. Would you agree that's what we have? Everybody agree? Okay, now here's what we need to consider. What we need to consider is first, if P is equal to 1, then we have Didn't we just do that one? Look. isn't that 1 over n to the 1 power? Everybody agree? So, I'm going to take that off, but what I'm telling you is, I've taken care of the case when p is equal to 1. I already know that. Huh? Obviously, when p is equal to 0, don't I get 1 every time? Don't I get 1 to the 0, 2 to the 0, 3 to the 0, 4 to the 0, and don't I just get a string of 1s? So now I need to know what happens otherwise. Do you agree? So what I'm going to do is, I'm going to use, again, I know what these mean, and I expect you to also, use the integral test. Well, that means that I have to consider the integral from 1 to infinity of 1 over n 1 over x to the p dp I dx. Is that correct? But isn't that equal to the integral from 1 to infinity of x to the negative p? Everybody agree with all that? Which I think is equal to x to the negative p plus 1 times 1 over negative p plus 1. Evaluated at 0, 1, and infinity. Isn't that the first thing I taught you in integration? Add 1 to the exponent and divide by the new exponent? Everybody agree? Okay? So now if I have, so that then is equal to 1 over 1 minus p. I just wrote it where the negative sign wasn't sticking out front, right? Times infinity to the 1 minus p minus 1 to the 1 minus p. You agree? No magic tricks, no smoke and mirrors. Isn't that just the way we do it? And I taught you, you remember, just so you remember, I'm sort of waiving formality in infinite series. I taught you to say that was, in the place of infinity, you put a b, right? And then you take the limit as b approaches infinity. I'm just letting you off without having to do this, because this is a means to get to the end, and I know what you're talking about. Okay? Now here's what I want to know is if p is greater than 1, then 1 minus p is negative. Does everybody agree with me there? So then could I say therefore, or that means that infinity to the 1 minus p is equal to 1 over infinity to 1 over infinity to some positive number 1 minus p. Doesn't the absolute value of it say make it positive? Yes or no? Yes or no? But doesn't that mean that it is 0? Back to what I said earlier, in infinity to any positive power is going to be infinity, right? Agreed? So isn't that equal to 1 over infinity, which is 0? Is that right? William?
I'm just trying to figure out what you did.
How about this, William? 1 over infinity to the point 0, 0, 0, 1 power. Whoops, it's got to be greater than 1, right? 1 over infinity to the 1.1 power. Isn't that just 1 over infinity? Infinity to some power is still infinity? Yes or no? Everybody agree?
This is kind of what you were talking about earlier, what a couple first numbers weren't really needed.
No, not even that. Well, yeah, that's not a bad way of thinking about it. Yeah, the first numbers don't matter. The fact is, it may not be approaching infinity real fast, but it's going to approach infinity, yeah. I want you to remember that any number divided by infinity is infinity, except for 0 and infinity. If you divide infinity by infinity, you don't know which one gets there the fastest, do you? And if you divide 0 by infinity, you still don't know which one gets there the fastest. So, 0 divided by infinity, I would rewrite that as infinity times infinity. Wouldn't you, Ed?
0 over infinity would still be 0, wouldn't it?
No, 0 over infinity, yeah, but I'd have to show that.
Okay.
All I'm saying, William, is that for any power positive number right here, that's going to be infinity to some positive number, which is still infinity. Okay? Everybody agree? So, doesn't that mean that the series converges by the integral test when p is greater than 1? So here's the p series. I'm going to just state it and then let you go. 2 is, if p is greater than 1, then s, that's the original series, s, converges. And 3 is if p is less than 1, then the series diverges.
Would you put a bar, we said p less than or equal to 1?
Well, I already look at number one. Didn't I do number one? So here's what I'm saying. If P is greater than 1, that series converges. Otherwise, it diverges. Okay? And I'll show you how to use that on Monday. I just have to stop here. All right, see you Monday. Cyrus, I sure thought I heard you say that about Ms. Hardy.
Didn't say anything bad about Miss Hardy.
Isn't that the truth? Isn't that the truth?